Hello students, welcome to another short video on our Small Steps Good Grade Secondary Science program. Today we are going to do lower secondary chemistry on separating techniques, specifically evaporation till dryness and crystallization. Let's go. So let us talk about some of the must know for evaporation till dryness and crystallization. Both evaporation till dryness and crystallization is for obtaining or separating soluble solute. Then what about insoluble solute? Insoluble solute, we are supposed to use filtration, all right? So when you are given any questions, the first question you should ask yourself is this solute soluble or insoluble in water? If you are given both soluble and insoluble solute, first thing to do, add water and the soluble solute will dissolve. Then you can perform filtration to remove the insoluble solute. I will go through the keywords for filtration in another short video. But for evaporation till dryness and crystallization, please take note, do not just write evaporation. It must be evaporation to dryness or evaporation till dryness. For crystallization, the soluble solute obtained is actually in aqueous state at first. So unlike evaporation till dryness, we will be able to get the solid solute when all the solvent has been evaporated. For crystallization, we will get the solution. For example, if we want to get sugar, we will have sugar solution, and then we will heat it to saturation, let it cool, crystal forms, then perform filtration to obtain the sugar crystals. Let's move on to other must-knows. Evaporation to dryness is only for heat-stable solutes like sodium chloride, also known as our table salt. For soluble solute that we are uncertain of its heat stability, meaning whether it will decompose upon heating, we should always use crystallization to obtain or separate the solute. Steps of crystallization. Now, students have to write certain keywords for the steps of crystallization in the open-ended questions answers. Heat the solution to saturation. So in the laboratory, we will usually heat the solution till 2/3 of the solvent has evaporated. Then we have to cool the solution. Crystals will form as solubility decreases with decreasing temperature. Lastly, perform filtration to obtain the crystals as residue. Open-ended question time. How do we separate salt from seawater? Answer: evaporation to dryness. Number 2, how do we separate sugar from sugar solution? Answer: perform crystallization by heating the sugar solution to saturation. Cool the solution and crystals of sugar forms. Perform filtration to remove the sugar crystals as residue. Why do we have to heat the solution to saturation for crystallization? Solubility decrease as temperature decrease. When a saturated hot solution is allowed to cool, the solute is no longer soluble in the solvent and forms crystals of pure compound. So imagine at 70 degrees Celsius, maybe 100 grams of the solute dissolves. However, this is at 70 degrees Celsius. However, at 25 degrees Celsius, only 50 grams of the solute is soluble. What about the other 50 grams? It will then crystallize and form crystals. And that is why we have to heat the solution to saturation for crystallization. Number 4, how does the rate of cooling affect crystallization? So do you cool the crystals slowly, or do you just put the saturated solution into a chiller? The size of the crystals depends on the rate of cooling. Fast cooling will actually result in a lot of small crystals, but slow cooling will result in smaller number of larger crystals. Number 5, what is the difference between filtration and evaporation to dryness separating technique? Filtration is for insoluble solute, right? Filtration is to obtain insoluble solute, while evaporation to dryness is to obtain soluble solute from the solution. Filtration is to separate heterogeneous solution, whereas evaporation to dryness is to separate homogeneous solutions. Number 6, distillation and crystallization can be used on homogeneous solutions. What is the difference between these separating techniques? And use an example of a homogeneous solution to support your answer. Now, yes, both distillation and crystallization can be used on homogeneous solution. Homogeneous solutions are solution that is uniformly mixed. An example will be sugar solution, copper sulfate solution, salt solution. Is homogeneously mixed, so you won't see sediments. Heterogeneous solutions will be called suspensions, like sand plus water. You will see sediments at the bottom. Distillation and crystallization, although they can be used on homogeneous solutions, they are used to obtain different substances. Distillation is used to obtain solvents, like our distilled water. Simple distillation is to obtain water. And crystallization is used to obtain solute from solutions. So for instance, distillation can be used to obtain pure water from sugar solution, and crystallization is used to obtain sugar from sugar solution. That's all. Thanks for watching this short video, and I hope this short video blesses you as usual. See you next time. Bye-bye.